The next topic is steps for solving problems using mole towns and just mole conversions in general. So if you don't know what mole town is, mole town looks like this. We have volume village, mole town, particle plaza, and mass mall. Each one of these is a place that you can go to, and these blue arrows in the middle are conversions. So you can go either direction. I could go from particles to mole and mole to mass. All of the problems that we can do here are 1 or 2 step. You can convert from one area to another. If you're doing conversions just using mole town, you have these rules down here to help you. Volume village has opposite rules, meaning that if you are going into town, you would divide by 6.02 times 10 to the 23rd. I don't want you to do the problems this way, but this is a good way to go back and check yourself to make sure you did all the conversions correctly. So, here are the steps to convert using mole town. Step number 1 is to use mole town to determine the number of steps that problem would require. Step number 2 is to create a chart and fill in the given information. Then you'll go back and add units. You'll fill in the conversion units, and then you'll cancel out the units, multiplied by the top, and divide by the bottom. So if I gave you a problem that said that you had 22 grams of copper and you were converting to moles, you would want to figure out in step 1 how many steps that is. So up here, I'm going from grams, a type of mass, to moles. So since I'm only doing one arrow, this is a one-step mole conversion problem. So that's step number 1. Step number 2 is to create a chart. So when I create my chart, my given information goes on the left, and then my number of steps will go on the right. So this is one step. If I needed to, it would continue. And I'll fill in my units and my given information. My given information is the part with the number, so 22 grams of copper. We'll go right here. You'll notice that I keep the units and the substance. And I keep them, we'll talk about substances later, but I keep the units especially for right now. My goal is to make my units cancel out. So if you watched our dimensional analysis video or took those notes, you know that if you have something on the top, to get it to go away, it needs to be on the bottom. So to get grams of copper to go away, I'll put it on the bottom. And my goal is to get from grams of copper to moles of copper. You can double check that you're able to do that using mole town. So I can go from mass to moles. And that's all that you need to do for step number 2. When we do this problem and when we add the conversion units, our grams of copper will cancel out, which was the goal. Step number 3 is to fill in the conversion units, which means I'll go back to this chart and I'll fill in the numbers. Mole town tells us that we're going to use the molar mass to do that. And remember, molar mass is the mass that is in 1 mole. So if I look on the periodic table, the mass of 1 atom of copper is 64 AMU. We're talking about moles of copper. So the mass of 1 mole of copper is 64 grams. Okay, that's the molar mass. The number 1 for molar mass will always go next to mole, and the number that you have for the mass will go next to grams, always. For the 4th step, we're going to cancel out our units. So grams of copper will cancel out with grams of copper, and we will be left with moles of copper. And then we are going to multiply by the top and divide by the bottom. So I'll do 22 times 1 divided by 64. Once you do that math, 0.34 moles of copper is your answer for this problem. So we were able to cancel out and convert using mole town. That's a simple one-step problem. I'll give you a couple more examples of these one-step problems, and you can use them using mole town. So the first one is to convert from moles to particles. And when we're converting from moles to particles, this is what we're doing right here. We're going to use Avogadro's number, and we are going to either go into town or out of town. If we're going from moles to particles, we're going this way. And when we set it up, we'll start with our 2.5 moles of zinc. The problem asks me for the number of atoms. Particles means atoms, molecules, compounds, anything like that could be for particles. So I want moles to go away. So moles of zinc will go on the bottom. And I'm trying to get to atoms of zinc. So it will go on top. We already proved with Moletown that we can do this in a one-step problem. And so I want to go back and I want to fill in my conversion numbers. 1 mole of zinc is 6.02 times 10 to the 23rd atoms of zinc. I'll make sure that my units cancel out. And I'll be left with atoms of zinc. Which means that your answer for this one is 1.5 times 10 to the 24th atoms. Your number of atoms are typically going to be very large, and your number of moles are typically going to be smaller numbers. No exponents. So for this next one, we're converting the opposite direction. So when I start this problem, it's giving me the number of molecules, 9.03 times 10 to the 24th molecules of water. Be careful when you're using molecules so that you don't get molecules and moles confused. They look pretty similar, especially if you abbreviate them in a similar way. So I'm going to be converting from molecules down here of H2O, and I put it on the bottom because I want them to cancel out. And then I'll be converting 2 moles of water. So I can use Moletown to figure out what number I need, and it's going to be Avogadro's number. That's the number of molecules in 1 mole. So 6.02 times 10 to the 23rd always goes next to your number of particles, and 1 will always go next to mole. I can make sure my units cancel out. Molecules of H2O is on the top and the bottom. I'll be left with moles of water. And then I can just do the math. And that would give you 15 moles of good old H2O. So that is particles to moles. We'll do one more simple conversion. And so it's how many moles of carbon are in 26 grams of carbon. So I will start with my given information, 26 grams. And this is grams of carbon. And the problem asks me to convert from grams of carbon to moles of carbon. So I can use Moletown. Mass is talking about my grams. So I'm going to be going from grams to moles in a one-step mole problem. So grams of carbon will go on the bottom. Moles of carbon will go on the top. And then I'll need to use my molar mass, which is what Moletown tells me. The mass of carbon in 1 mole. So the mass of carbon according to the periodic table is 12 grams. That number will go next to grams, and next to mole I'll put a 1. So 26 divided by 12 will be what I type in my calculator. Grams of carbon will cancel out, and I'll be left with moles of carbon. So if I do that math, I get 2.17 moles of carbon as my answer.